Okay, hi, this is Mrs. Myers, and today we're going to be learning section 11.3, surface area of pyramids and cones. By the end of this lesson, you should be able to know the definition and be able to find the lateral area and the surface area of pyramids and cones using the formulas and all of the parts of the formulas. A pyramid is a polyhedron that has one base. Okay, this is different than our prisms, which always have two bases. Okay, but the one base, which is a polygon, and the lateral faces that meet at a vertex, since there's a base and a one vertex at the top, all of the lateral faces are going to be triangles. A pyramid is named by the shape of its base, just like a prism is named. So in the case of this pyramid here, I think I did 6 sides on the base. That would be a hexagonal pyramid. The altitude of the pyramid is, again, altitudes are always perpendicular from the vertex to the base. So that's the altitude, and so the height is going to be perpendicular from the vertex straight down to the middle of the base there. The length of the altitude is the height of the pyramid. Remember, it's the distance. Now instead of the distance between the two bases, it's the distance from the vertex to the base. Remember, it has to be perpendicular to the base. Right, a regular pyramid just means that its base is a regular polygon. So the base has all the same lengths of sides and interior angles, which means all of the triangles, like we said up here, the triangles that are the lateral faces, all these triangles are going to be congruent triangles. The slant height, which is denoted with a lowercase script L. I know it's kind of strange, but a lowercase script L is the slant height. So fill that symbol in here. Is the length of the altitude of a lateral face. If you look at this diagram here, it's easier to talk about the slant height. The height itself goes from the vertex to the base, like we just defined, but the slant height is this one that goes here. This is the slant height. It goes from the vertex perpendicular to one of the sides of the base. So it's actually, it's a good word, slant height. It's like the slanted height. If you look at the net of this pyramid, you can see that each lateral face is a triangle. The slant height is the height of that triangle. So that's what it says here. It's the length of the altitude of the lateral face, the triangular lateral face of the pyramid. So that's the slant height. The lateral area of a pyramid is the sum of the areas of the triangles, so everything without the base. So just like with the prisms, the sides, the lateral faces, is everything except the base. Okay, now this is a really key point right here. You want to put a little star next to it, circle it, highlight it, whatever you want to do. But finding this hidden triangle in a pyramid is key to solving for the surface area and volume. The hidden triangle that I'm talking about is this triangle here. The apothem, the height, and I'm going to make it blue now, the slant height. So that triangle, which is a right triangle, is the key because sometimes we need to solve for different parts of that triangle. I'm just going to highlight it here. This triangle in here. Okay, if I highlight it in this one, it's the height, the apothem, and the slant height. There's the triangle in that one. Okay, that triangle, just kind of like part of the cross section, it's like hiding in there. That's going to be key to finding the missing pieces here. Let's highlight this one. Hidden triangle here. There's the height, the apothem, and the slant height. That makes that triangle. Here, height, apothem, and slant height. Actually, these diagrams here used S for slant height, but we're going to use L. Sorry, took those off the internet. Okay, that's the triangle that we're going to be looking at. Now, the formulas for finding the lateral and surface areas of a pyramid. Lateral area is 1/2 PL, where P is the perimeter of the base, and L is the slant height, lowercase script l. To find the total surface area, all you're going to do is add 1b, because there's only one base. So remember, with prisms, it was surface area equals pH plus 2b, because there was two bases. Now it's just plus 1b, because there's one base. Now, this 1/2 PL, lateral area. Remember, we're finding the area of all of the sides, the lateral faces. The lateral faces here are all triangles. The area of a triangle is 1/2 base times height. 1/2 base times height is equivalent to the 1/2 times all the bases together is the perimeter times the slant height. So that's why it's 1/2 PL, because it's related to the formula for area of a triangle. So surface area, total surface area, is 1/2 PL plus the one base. Okay, again, we are going to make a list. This time our list has to include a couple of other things. We need P for perimeter, we need L for slant height, we need area of the base, and I'm still going to go with height, because in most cases you are going to need the height to find the volume anyhow. So even though it's not in this formula, we're still going to find it. Often you need it to be able to use that hidden triangle I was talking about anyway. Okay, so what's the surface area of this pyramid? Let's fill out our list. First of all, the base is a regular hexagon. Each side of the regular hexagon is 6, so the perimeter is going to be 6 times 6, or 36. Slant height is shown to us here. They give us the slant height is 9. Area of the base. Well, they were nice and they gave us the apothem. They didn't need to give us the apothem, did they? Because we know it's a regular hexagon. Side is 6. Therefore, the apothem is half of the side times the square root of 3. So apothem is 3√3. Area of the base for a regular hexagon is 1/2 AP. That's the area of the base. So we're going to do 1/2. Apothem is 3√3. Perimeter, we said, is 36. So when we multiply this out, we get 54√3. Now, the height of the whole pyramid, okay, I guess we don't really need it in this case, so we don't need to use it for this one, because they didn't ask us to find volume. All right, so surface area, 1/2 PL plus 1 base. 1/2 Perimeter is 36. Slant height is 9. Plus area of the base is 54 root 3. Let's figure out what the approximation of 54 root 3 is. If we do that on our calculator, 54 root 3 is about 93.53. Well, that way we can get both exact and approximate. So we're going to do 1/2 36 times 9, and we're going to get 162 plus 54 root 3. If we were asked to find the exact surface area, we would leave it just like this, square inches. If we wanted approximate, that's 162 plus our 93.53, and that's 255.53. Sorry, it got squishy there. Okay. Sometimes this hidden triangle that we were talking about before is going to help us to find the area, or the surface area. Let's look at number 2. A square pyramid has base edges of 5 and a slant height of 3. Actually, let's skip that one. Let's do number 3. What is the surface area of the pyramid round to the nearest square foot? Okay, so here if we make our list, we need P, L, and B. Sometimes H is going to help us. In this case, H is definitely going to help us. Okay, so we know that one side of this hexagonal base is 36. So to get the perimeter, we're going to do 36 times 6, which is 216. Slant height, they don't tell us. So we'll have to come back to that one. Here's the slant height. That's not labeled. They do give us the apothem. Apothem is 18 root 3. So that's going to help us with our 1/2 AP area of the base. We're going to do 1/2. Apothem is 18 root 3 times perimeter, which is 216. So 216 times 18 times 1/2 is 1944 root 3. Let's make this approximate because it says round to the nearest. So 1944 times root 3 is 3,367.1. Actually, it's 0.11. That's the area of the base. Okay, the height they give us as 42. Okay, so we have this problem that we don't have the slant height, and we need it for our surface area formula, 1/2 PL plus B. Well, we have everything else. We have B, we have P, we know 1/2, but we don't have L. We don't have that slant height. This is where that hidden triangle is going to help us. Okay, so I'm going to redraw the triangle here. That's 42. It's the height. This is the apothem, 18 root 3. And this is the slant height. So we have a right triangle, and we know 2 sides, and we're missing the 3rd side. So what do we do if we want to find the 3rd side? We use Pythagorean theorem. Yes, Pythagorean theorem is going to be used a lot with pyramids and cones. So we need to do, where should I do this here? 42 squared plus 18 root 3 squared equals L squared. 42 squared is 1764. Now, 18 squared is 324, and then we have to do times root 3 squared. Well, root 3 squared is just 3. So I'm going to do 324 times 3 is 972. When we add these two numbers together, we get 2736 equals L squared. So L is the square root of 2736. And that's 52.31. So the slant height is 52.31. Okay, so we needed the height, not for the surface area, but we needed the height to be able to find the slant height. Now we're going to plug in. 1/2 perimeter was 216. Slant height is 52.31. Area of the base is 3,367.11. When I do 52.31 times 216 times 1/2, I get 5,649.13, and I'm going to add that to 3,367.11. And I'm going to get 9,016.24. It says round to the nearest square foot, so 9,016 square feet would be my rounded surface area. Okay, there are a couple of other problems in here that we can practice finding the surface area using Pythagorean theorem. This got cut off a little bit. That should be a 30. Using Pythagorean theorem to be able to find the slant height. Look at this one down here. They give us the height is 36.4. They give us this whole side of the square is 30. If the whole side of the square is 30, what's the apothem going to be? That's just half of the side. So when I redraw this triangle, I've got, make this red again like I did last time, 36.4 here, and I've got 15 down here because it's half of the side. And then I'm looking to use Pythagorean theorem to find the slant height again. Okay, so I'm going to let you try that one on your own. This video is getting a little long, so let's look at cones really quickly. The base of a cone is a circle. And so the slant height, again, is L, and it's the same idea. It's just this slanted from the bottom to, from the base to the vertex along the lateral face of the cone. So again, cones have hidden triangles too. Height, in this case, instead of apothem, it's radius, and slant height are going to make that hidden triangle. Same concept then. We're going to use Pythagorean theorem a lot to find the missing pieces of that triangle often. And that's going to help us with our formula for lateral and surface area of cones. Oops, this got cut off, of cones. So surface area is 1/2 CL plus B. Remember, with pyramids, it was 1/2 PL plus B. Well, the perimeter of a circle is a circumference. So 1/2 CL plus B. Another way to think about it, if you take 1/2 of the circumference, right? Circumference is 2 pi r. If you take half of that, it's just pi r. So another way to think about the surface area formula, and sometimes we actually need to think about it in this way, because sometimes they're asked to solve for r, okay, is to think of it as, instead of C, replace that with just pi r L plus, and then B for area of the base, if it's a circle, is pi r squared. So we have pi r L plus pi r squared. Okay, so again, using this triangle that's hiding in here, we're going to make our list. This time we need circumference. Again, I would start with radius, circumference, slant height, area of the base, and again, height is going to be was going to come in handy sometimes when we need it for Pythagorean theorem. Okay, I'm going to end this video now because it's getting a little bit too long, and I'd like you to try this problem on your own, and we'll go over it in class. I may make a second video with all of these answers filled out, or possibly just post the answers to these so that you can check them at a later time. Okay, so remember, two more formulas. We've got surface area of pyramids, it's 1/2 PL plus B, and surface area of cones is 1/2 CL plus B, or pi r L plus pi r squared. The key here, again, is this hidden triangle in the pyramids and cones, and often we need Pythagorean theorem. Okay, talk to you soon. Bye.